Okay, so today's lesson, exercise 14a, we're going to do the content unordered selection. Now, unordered selections means when the order is not important. Previously, I gave you a chart about like a flow chart about like a permutation combination question. If order is important, so like for example, if A, B, C is different to A, C, B, then this is permutation type of question. However, if A, B, C and A, CB and BCA, if they are all considered to be one sort of combination here, then this is the combination question. Okay, so we're going to talk about this one in detail today. Alright, so we'll just start with a very simple example to begin with. So let's just say, for example, if we have four letters A, B, C, D, and then we're choosing 3 letters from all these 4 letters here, and the order is actually important. So we'll choose 3 letters. This time order is important. Okay, and let's find out how many different arrangements are possible. Okay, so if this is the case here, we're going to select the 3 letters at a time. Obviously, if we know the form, if you're using the formula, the answer is actually pretty easy to work out. All right, so the formula just tells you that we've got 4 letters here, so it's 4p3. Okay, and then we can actually use the formula to calculate the number of arrangements, which is 4 factorial over 4 minus 3 factorial, which gives you 4 factorial over 1, and that is equal to 4 times by 3 times by 2 times by 1, and then it should be 24 different arrangements there. Alright, so what I'm going to do is I'm going to try to list all the 24 different arrangements, and then we're going to talk about what happens if the order is not important, and then how many different arrangements are possible in this case here. Alright, so if we just say, starting with here, we'll start to pick ABC. That's my first selection, ABC. Okay, so we can select ABC. However, once we have selected ABC, there's 3 factorial ways to organize ABC, because we can rearrange that into ACB, and then BAC, BCA, CAB, and CBA. So in total, we have 3 factorial ways to organize 3 elements after choosing from 4 elements there. Alright, now so the question here becomes a really simple question. How many different 3 choices is possible, right? So we can choose ABC as the first group, and we can start to choose more. So let's have a look. Alright, the first one is ABC, alright, with these 3 letters. Now we can choose A, B, and D. So we'll just keep doing it. A, B, and D. Now remember, with A, B, and D, I'm not going to list all of them. You'll have another 3 factorial ways of organizing A, B, and D. Alright, so once we finish that, then let's move on to, since I have already used these 2 letters here, now I'm just going to start using these 2 letters. Alright, so we're going to use BC to begin with. So it'll be BCD. Again, we're going to have 3 factorial ways to organize BCD. Alright, and then can we have BCA? Well, if we choose BC and A here, it's just going to be the same as ABC, so we don't choose BCA anymore. Alright, so once we have finished the BC one, now we're going to just move on to CD. Alright, so it will be CDA. So now CDA, again, within the CDA, there are 3 factorial ways of, rearranging CDA. So in total, 3 factorials is equal to 6, and we have 4 groups of 6, which is 24, and that is 24 here. Alright, so what does that mean is, if you look at this one, it's actually pretty clear. We have 4 groups. Okay, we can choose 4 groups out of these 4 letters. When we are actually selecting 3 letters from these 4, we can have 4 groups. Okay, this is actually really important. So, based on this calculation here, it's like we'll have 4 groups of 3 factorials. Okay, and then that obviously gives you 4 times by 3 factorials is equal to 24 here. Alright, so then when we're dealing with the unordered selection, so if the order is not important, okay, so if order is not important, what does that mean is ABC, BAC, all of these are considered to be one, okay, arrangement, or one combination. Okay, we're talking about a combination here. I just need that particular combination. The order is not important as long as you have A, B, and C, those 3 letters in that group, and then everything is fine, okay? All right, so we've got like 1, 2, 3, 4, 4 combinations of letters, of 3 letters, and then so that it says 4 groups, but it's like 4 combinations of like 3 factorials. So if order is not important, we don't need that 3 factorial anymore. Okay, so we just only have 4 combinations if order is not important. Okay, if order is not important, what happened here is we're going to have like in previously 24 total possible ways of organizing this, right? But now the answer will be just equals to 24 divided by 3 factorial, because we don't need that 3 factorial ways of anymore. Okay, so after you're selecting 3 letters, there is no need to organizing those 3 letters anymore. So that becomes 24 over 3 factorial, which actually gives you 4 groups, okay, or 4 combinations. Alright, so this obviously leads us to another formula that's very similar to the 4p3. This time, you can actually use your calculator. If order is not important, you can use your calculator and write down, write down 4c3. Okay, so you've got 4 elements, you're choosing 3 elements, okay, the order is not important, and then that gives you the answer. Now, what we need to do is we actually need to look at the the relationship between 4c3 and 4p3. There is a relationship between these two, these two expressions here. The actual formula is actually pretty easy to, to understand. Alright, so 4p3 is when order is actually important. So you're selecting 3 items or 3 elements from 4 elements. Okay, so you're selecting any 3 of them, and then you rearrange within these 3 elements. That becomes 3 factorials. Okay, however, if I want to find the combinations, right, then we need to simply divide it by 3 factorials. So 4p3 is equal to 4 factorial over 4 minus 3 factorial. And then in order for us to actually change that into the 4c3, we simply divide it by another 3 factorial here. Okay, because within that 3 elements, we don't need to rearrange these 3 elements. Like A, B, C is the same as A, C, B. So there's no need to rearrange that 3 factorial ways of the permutation of A, B, C here. So we divide by 3 factorial, and that's how we actually get the answer. So therefore, there is a formula, okay, for 4C3, or there's a formula for NCR. All right, so the actual formula is this. NCR is equal to NPR. So first one, you have an NPR ways of rearranging it, and then you simply divide it by R factorial, because within that, if you're choosing 3 elements, within that 3 elements, you don't need to rearrange it. If you choose like 5 elements out of 10, that within that 5 elements, you don't need to rearrange it. All right, so that's what happened. Okay, so NCR is equal to NPR over R factorial. Now, we know that NPR is equal to N factorial over N minus R factorial. And if we divide by R factorial again, eventually we'll get the formula N factorial over N minus R factorial and R factorial. And that is the formula for NCR. Okay, and this formula, that is something that you need to remember. The proof is actually just based on the previous example question here. It's very simple. I hope you guys understand it. Okay, so we've got 2 formulas here. So let's write this one more time. NPI is equal to N factorial over N minus R factorial. And CR is equal to N factorial over N minus R factorial and then R factorial. Now, there's one more formula that you need to know, which is NCR is also equals to NCN minus R. Okay, now probably I don't need to put a bracket here. All right, so just N minus R. Now, why? What's the reason why NCR is also equal to NC N minus R? What does that mean? So let's just say, for example, if we have 5 letters, 1, 2, 3, 4, 5. Okay, we'll have 5 letters. Okay. So if we are choosing only 2 letters at a time, okay, so if we're choosing just these 2 letters at a time, the number of different combinations, we know that's 5C2. But if you think about this, right, choosing 2 letters at a time, all right, it's very similar to, on the other side, it's like instead of choosing 2 letters at a time, you're choosing 3 letters at a time. So instead of like, just doing 5C2, we can just choosing 3 letters at a time, which is 5C3. And these two are actually equal to each other. All right, the number of combination is the same if you think about it this way. All right, since if you're choosing 2 at a time, then you actually left the 3 elements out. All right, so it's like you're choosing 3 elements at a time. So these two are actually equals to each other. All right, in the meantime, like you can also sort of prove it using the, not really prove it, but show they're also equal to each other, because if you just look at the actual calculation, 5 minus 2 factorial and 2 factorial, compared to the sides on the right hand side, you've got 5 minus 3 factorial and 3 factorial. Eventually the denominator are just equal to each other. 5 minus 2 factorial is just equal to 3, so that gives you 3 factorial, and then 2 factorial is just equal to the 2 factorials here. All right, so this is something that you need to please remember. It's actually very interesting. All right, and later the combination is we're going to deal with the combination in terms of the Pascal triangles as well. So like this triangle is also related to the combinations. All right, so all of these numbers here in the front are the coefficient when you're expanding the binomial, like a plus b to the power of n. And again, later we're going to deal with that. All right. Okay, so let's have a look at the type of question you're going to get in this exercise. The question is it's actually pretty, I would say pretty difficult. Okay, it's not very easy, and there will be some interesting and difficult question to start with. All right, so let's just start with something that's very simple and straightforward, and then we'll move on to something that's a bit difficult. Okay. All right. So the first level question is very elementary using the formula type. Okay, so it will be questions like use the formula NCR to evaluate. All right, so like obviously without using a calculator, the question asks you to evaluate 8C5. Okay, so if that's the case here, that's easy. We're using the formula 8C5 is equal to 8 factorial over 8 minus 5 factorial and 5 factorial. Okay, which means that's equal to 8 factorial over 3 factorials and 5 factorials, and we just need to continue the process. 8 factorial is equal to 8 times by 7 times by 6 times by 5 factorials. All right, and 3 factorials is 3 times by 2 times by 1 times by 5 factorials. And we can cancel the factorials, both 5 factorials, both the top and the bottom. We can also cancel the 2, 3 with the 6. So at the end, we get 8 times by 7, which is 56. This is just using the formula to, simplify. All right, so another example would be something not in terms of just numbers. All right, they can also give you questions like NC3 and ask you to evaluate or simplify. All right, so if we get NC3, we're now applying the formula that's just n factorial over n minus 3 factorial and 3 factorial here. All right, and then what we need to do is we can unrolling the factorial notation for the numerators that give us n minus 3 factorial times by n minus 2 times by n minus 1 and times by n. And that's how you actually get n factorial for the top, right? The reason I want to do this is just because I want to cancel the n minus 3 factorial on the denominator. So like this, we can cancel these two out. So we'll end up with n minus 2 or n minus 1, n minus 2, and denominator is just equal to 6. All right, okay, so this is something that's really simple, okay? Now let's look at some actual questions. It's going to be pretty interesting. All right. So let's move on to example 2. For example 2, I'm just going to find the question from the exercise. All right, and we're going to do it together. So let's just start with something that's really simple, and we'll go from there. All right. Okay. All right, so question 7. Okay, so that's the question 7 from the exercise. All right, so the question says a committee of 5 is to be chosen from 6 men and 8 women. Now, the question asks you to find how many committees are possible if all right, so the first question, a couple of questions there. So the first question here is if there's no restriction, all right, if there are no restriction at all. Now remember for the combination question that we also have restrictions. Sometimes a person does not want to be in the committee with another person, so you have to actually, take into consideration of the case here. All right, so question 7. A committee of 5 is to be chosen from 6 men and 8 women. How many committees are possible if there are no restrictions? Which means you can choose any combination. You can have you can have all women, or you can have all men. So there is no restriction at all for a question like this. All right, so in this case here, it's actually pretty easy. There's no restriction. The order is not important. So it's like, as long as you have 5 people in a committee, it doesn't matter with the order. You don't have to say, oh, that person is the first place or the other person is the second place. We just need to make sure that those persons are in the group. That's all. So if there's no restriction, we just need to find out the total people here. So we've got 6 men and 8 women. All right, so let's highlight this. So in total, we have 14 people in total, and we only need to select 5 from 14. Okay, so if we just select 5 from 14 from total of 14, in that case here, then the answer would be just 14C5. Remember, order is not important, it's just 14C5. And then obviously you can use your calculator to simplify this. And 14C5 is equal to 14 factorial over 14 minus 5 factorial and 5 factorial. Of course, you can do it like in a pen and paper, but in this case, I would suggest just use your calculator to work out the answer there. All right, so that's pretty easy. If there's no restriction question there, straightforward. Okay, now let's look at if we have some restrictions here. If the question says all members has to be female. So all of those 5 members has to be females, right? Are to be female. All right, so how do we do that? We're selecting 5, right? In total, we still need to select the 5. However, they all have to be female, all right? Which means we can't select it from the group of men here. We have to select from the group of women, all right? So in this case here, we're only selecting, 5 from 8 women, all right? So this is the idea. You're selecting 5 from a total of 8. You're not selecting 5 from a total of 14. We automatically remove the men there, okay? From a total of 8. So therefore that becomes 8C5. Alright, so which is equal to 8 factorial over 3 factorials and 5 factorials there. Alright, so that's also pretty easy to do. Okay, so that is again question B. Alright, let's move on to question C. So I'm just going to copy this question there to the next page. Alright, so the next question here, question C, it says all has to be male. Alright, so that's easy. Alright, so we're probably just going to skip the question C. Alright, question C, we'll just do it. Okay, so all members are to be male. So that's a really simple one now. Alright, so we're selecting from a group of 6 men here, we're going to select the 5. So therefore, if all are male, then the answer will be just 6C5. Right, and that becomes 6 factorial over 5 factorial and 1 factorial, and that's all. All right, next. Now the next one, exactly 2 men. All right, so we're gonna have a committee that there are exactly 2 men. All right, so how would you do this question here? Exactly 2 men here. Well, for this question, all right, now we need to think about groups here. So we have 6 men in total, and how many women? We've got 8 women in total. Okay, now we are going to select 2 men, exactly 2. So we can only select from a 6, and then the answer here will be 6C2. But once you have selected 6 of them, all right, then we still need to select the remaining 3, all right, to cover. Obviously to cover the group, right? Because total we need to select 5 people in total. So therefore, we can't select another 3 from the group of men here. We have to select 3 from the group of women. And in this case, we've got 8C3. So in total here, as you can see, 2 plus 3 is equal to 5 people in total. All right, now in between it is just multiplication. So multiply 2, all right, together, that gives us the answer. And that's how we actually work out the answer if we are selecting exactly, 2 men. All right, question E. There are 4 women and 1 man. All right, so 1 man. Oops. All right, so again, similarly, we have the same question here. We've got 8 women. Oops. All right, we'll have 8 women here. We need to select 4 from 8 of them. All right, so therefore that's 8C4. We need to select 1 man from 6 men. So that gives you 6C1, and we multiply them together. All right, so it's very similar to the previous question. All right, now we are just going to have something that's a bit difficult this time. So question F. I'll probably just do question F here. All right, so question F is going to be a slightly difficult. All right, question F says there is a majority of women. So the question asks you how many different communities are possible if we have a majority of them are women. Now we need to talk about this one in terms of cases. Majority of women, all right? So let's just again write down the number of people here. So we've got 6 men, 8 women. And remember we're selecting 5. Selecting 5 people. Okay, majority of them has to be women here. So this is the pretty interesting case. So we have case 1 where we're selecting all 5 women. So 5 women. All right, 0 men. That's the first case. Now case 2, we have 4 women. So yes, we'll have to talk about this one in terms of cases. Case 3, we've got 3 women and 2 men. All right. Again, remember, you can't have 2 women and 3 men here because otherwise it's not majority. All right. So if it's a majority of them, all right. So this is what happens. We've got 3 cases. So in each case, we're just going to work out the combinations. Right. So that will be 8C5 times by 6C0, and this is 8C4 times by 6C1. And the last one is 8C3 times by 6C2. All right, then in total, we are actually adding these 3 groups together, okay? It's because we have 3 different cases, so we need to add these 3 groups together, and that gives us the final answer. All right, so the final answer to this question here is you need to use your calculator to work out this answer there. C1 plus 8C3 times by 6C2, okay? All right, so that's what happened, and that's how you do the question where it says majority of them are women. All right, now next one, question G. Now a particular man must be included. Okay, that's a really interesting question now. A particular man must be included. All right, so how would you do this question? A particular man has to be included. Well, again, let's just write down how many people we have. 6 men, 8 women. Now, we need to select the 5 again, but 1 particular man has to be included. So in this case here, what happened is, if you think about this, right, we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Think about it this way. If I'm just using a diagram to make this maybe easy for the student to see. All right, if 1 particular man has to be included, so let's just say this particular man has to be included. Okay, so that person is already in the group or in the committee. What does that mean is we don't need to select that person anymore. Okay, this person is already in the group. Now, if that person is already in the group, all right, previously we need to select the 5. Now we only select 4 because that person is already in the group. All right, and there's no other restriction for the rest of the other people here, so we don't have to worry about the other people there. The question didn't say about how many women or men has to be there. The question only tells you that 1 particular man has to be there. So in that case here, what happened is we have 1, 2, 3, 4, 5. 5 plus 8, which is 13 people in total, and we just out of these 13 people, we just need to select 4. Okay, because please remember we already selected 1 and that person is already in the group automatically, so therefore the final answer is just 13C4 because we have already selected that particular man here. All right, that's how you do it. All right. The next one is question H. A particular man must not be included. Oh, so this time we're not including that person. Must not be included. All right. So how do we do this question here? Now we can use the complementary event to do this question. For the previous question, that particular man has to be included. All right, so the complement of that is this particular man is not going to be included. So we just need to find the total number of combinations, which we had it before, and that was just like 14C5. Okay, 14C5, and then we just need to minus 13C4, and that gives us the answer. And the answer here will be just the answer for what that particular man must not be included. Now remember, this is the total arrangement, okay, or sorry, total selection. Shouldn't use the word arrangement because of arrangement means the order is actually important. This is the total selection that a particular man is included. So therefore, if you use the complementary way, that particular man is not included is just equal to the total selection minus the total selection that the particular man must be included. All right, so this is how you do this question here. Okay, all right. Now, let's move on to something that's a bit difficult. Okay, let's just call this an example 3. Okay, let me just find out questions here. All right, how about this question? So what about if we have a questions where it's a sort of a geometry question, like, we've got a circle, and on the circle we have 10 points, right? So that's 1, 2, 3, 4, 5, any 10 points, 6, 7, 8, 9, 10. They don't have to be equally spaced out, all right? So we'll just have like 10 points arranged in order around the circle. All right, now the question here, or the first question, it says, how many triangles can be drawn with these points as vertices? Okay, so while I'm writing the question down, all right, think about it. How many triangles can be drawn with these points as vertices? All right. Okay, so the question here is it's pretty simple, right? If you think about this, right, a triangle would just, all right, so if we pick any 3 points, all right, it seems this is a circle, so there will be no 3 point that forms a line, so you don't have to worry about it. There will be no 2 points that forms a line. Or actually 2 points will form a line, but no 3 points form a straight line. So it will always be a triangle if you just pick any 3 points on the circle. All right, now the order is not important because if, for example, if I just pick 1, 2, 3, it doesn't matter if it's 1, 2, 3, 3, 2, 1, 2, 3, 1. These are the 3 points. The triangles you can have is just that. All right, you can't have any other triangles. So in that case, so the first question is actually pretty easy to understand. We have 10 points in total. We just need to select any 3 points. All right, so we can select a point here, a point there, a point here, and we can connect them. That's the one triangle. And this triangle is going to be a unique triangle comparing to another triangle here if I select 2, 3, and 9. So in total, there will be 10C3 possible ways to select, to form a triangle without any restrictions. Okay, so that's the first question. Pretty easy. Now the second question is, how many pairs of such triangle can be drawn if the vertices of the 2 triangles are distinct? All right, again, distinct means they are different. So how many pairs? So within this 10C3 number of triangles, how many pairs of such triangles can be drawn if the vertices of the true triangles are distinct? All right, now distinct means if you pick, for example, if you pick 1, 2, and 3 to form a triangle, then if you pick 1, 2, and 7 to form another triangle, and then these are not distinct anymore, since because you are actually using the points like, several, 2 times. So you can't use the point like this is a distinct triangle comparing to this one here. Okay, so that's the idea. So now the question asks you how many pairs of triangles are distinct. Okay, now we need to think about this. We need to form 2 triangles this time. Now, if we want to form 2 triangles, basically we'll just think about if there's no restriction and if I want to form 2 triangles, how many points do we need? Okay, think about it. I guess we need to choose 6 points, right? So we need to choose 6 points out of 10. Okay, so that's the first thing we think about it. So to form 2 triangles, okay, we first choose 6 points out of 10. Alright, so mathematically this is going to be 10c6. Alright, let me just use my calculator to work out what's 10c6. Alright, so that's equal to 210 times. Alright, let's work out the previous one as well. That is equal to 120 triangles. Alright, so 210 different ways to form 2 pairs of triangles using 6 points. Okay, now when you think about it, right? So let me just highlight any random 6 points. Okay, so 1, 2, 3, 4, 5, 6. Okay, so these are the 6 points I'm chosen. All right, okay, now if we just take any one of these 6 points, then we just choose the other 2 points in its triangle, then this can be done 5c2 ways. So what does that mean is, if I just pick this point here, okay, if I pick this point, now you have 1, 2, 3, 4, 5 points left. If I pick up number 10, you have 5 points left, and within that 5 points, I just need to choose 2 more points to form a triangle. Okay, so therefore, that will be 5c2 ways. Alright, so let me just again use my calculator, and that's equal to 10 ways. Alright, so therefore the second triangle now can be drawn using the other 3 points. So therefore the number of pairs of triangles is going to be 210 times by 10, which is equal to 2,100. Okay, ways. Okay, alright. Now, if a student still don't understand what's going on here, I'm just going to explain to you one more time. The reason, firstly, I need to have 6 points is because, remember, the vertex has to be distinct, so you can't use the point once. Does that make sense? Okay, has to be distinct. All right, so you can't use this point more than once. So that means we'll have to pick 6 different points. Okay, so the number of ways to picking 6 different points is 10c6. Which are 210 ways, because remember, I don't have to pick all of these 6. I can pick another like 1, 2, 3, 4, 5, 6. So in total, there are 210 ways to pick 6 points out of the 10 points around the circle. After we finish that, right, then we start to think, within these 6 points, how many different triangles you are going to get. Okay, so this can be done is like if you just pick a random point, if that point is set, alright, then how many points you need to form a triangle? Well, you need 2 more points to form a triangle. So you can pick any 2 points from a combination of 5 points there. Okay, so you have 5 points left, but I just need to find 2 points. Alright, so say for example, if I pick a point 8, I pick a point 10 and I pick a point 8. So that forms a triangle, and the remaining 3 points forms another triangle. Okay, so that way we have 10 triangles in total. So now there are 210 ways to pick 6 points. Within the 6 points, you have 10 ways to form 2 triangles. So therefore, if you times them together, in total you have 2,100 ways. All right. Okay, now let's move on to the last part of this question, which is the most difficult part of the question. The last part of the question here says, in how many ways such pairs or triangles were not overlapped? in how many such pairs were the triangle not overlapped. All right, so here's an example of not overlapped. All right, so if I just pick, all right, so again, all right, so let's just start with this. All right, first we still need to have 210 ways to pick 6 points. Remember, we still need 2 triangles. So in total here, we still have 210 ways to pick. Okay, so 10C6 is still there. That is just picking, like choosing 6 points out of 10. All right, so this is still works. All right, we still need to pick any random 6 points from 10 points. So now, say for example, these are the 6 points I picked. Right, then the triangle that's not overlapped. Now, let me just draw a triangle that's not overlapped. All right, so right now, as you can see, they are not overlapped. All right, but when does the triangle overlap? All right, again, I think about it. If I decide to draw a triangle this way, all right, and you can see the 2 triangles are actually overlapping. All right, so we need to now think about how do we draw triangles that's not overlapped. All right, and how is that possible? Okay, all right, so how do we do it? These 6 points can be made into 2 non-overlapping triangles in 3 different ways by arranging the 6 points in the cyclic order and then choosing 3 adjacent points. All right, so if you think about this, have a look at the previous example I used. If I just used 3 points, okay, that's adjacent to each other, so I'm not choosing 10, 2, and 5, which there's a point that's in the middle that separate them. If I just choose the 3 adjacent points, you know, this 3, and then this 3 points becomes, you know, adjacent points as well. For example, if I just choosing these 3 adjacent points to form a triangle, and then the remaining points will form another triangle which is not overlapping. All right. So then the question is, how many different ways are possible? Okay. So this is pretty easy. If we can just use like a normal counting method. If we choose like a 2, 10, and 8, that's 1. Okay, that's 2. And then that's 3. All right. Now, is that 4? Think about this. If I choosing this 3, is that 4? No. All right. Because if you're choosing this 3, that's just going to be the first case where you're choosing 2, 10, and 8. So there are only 3 possible triangles that's not overlapping. Only 3. Okay. So 3 are not overlapping. 3 triangles, or 3 pairs of triangles. I would say 3 ways. Okay, 3 ways that's not overlapping. That 2 triangles not overlapping. Alright, so therefore we have 210 ways to choosing 6 points from the 10 points, times by 3 points here, 3 ways, so it becomes 610 ways of the triangles that's not overlapping. Okay, all right, now if the question asks you about how many triangles there are overlapping, well, in that case you can use the complementary ways. Okay, so you can use the method where we actually find out that the total triangles we'll have is 2010 ways, or 2010 triangles possible, then minus 610 triangles which they are not overlapping, and then that means the rest of them are overlapping. All right, so this comes out to be a pretty difficult question when you first look at the questions here. Now, please, this exercise is extremely important. Please spend time to do it. If you have any question, let me know. I'll just do one last question to finish off the lesson. This question is actually coming from the textbook. Okay, so I'm just going to do question 20. Right, so question 20, it says, in how many ways can two numbers be selected from 1 to 9 so that their sum, if you add them together, is first one even. Alright, so have a read the question one more time and think about how would you do this question here. All right, so the question says, in how many ways two numbers must be selected? So we're only selecting two numbers, okay? And then their sum must be odd. Oh, sorry, must be even, not odd, okay? Now you need to think about how is that possible? How do we select two numbers when the sum is, is even? All right, so let's just list all the numbers out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I wanted you to think about this, all right? To have an even sum, there are two possible ways you can get two even sums, right? You have even number plus another even number. That's the first case. The second case is you have an even number plus an odd number. Wait, even number plus an odd number? No. Because even number plus an odd number is actually an odd number. All right, I'm not correct here. So it's actually an odd number plus an odd number. Yep, 3 plus 3 is even. All right, because an odd number, if you think about this, odd number could be just like n plus 1, and then another odd number is another n plus 1. So in total will be 2n plus 2, which is 2 times by n plus 1, and that's an even number here. All right. So what we are going to do now is we need to find out how many even numbers there and how many odd numbers there. That's 1, 2, 3, 4. So we've got 4 even, and 1, 2, 3. Wait a minute. 1, 2, 3, 4, 5. 5 odd. Okay, so to do this question, it's actually pretty easy now. So we either have both even numbers. So therefore, both even numbers will be 4c2. Or the second case is we either have both odd numbers, and that's 5c2. So therefore, the total possible ways is equal to 4c2 plus 5c2. Now this time you're using plus instead of times because we're talking about two different cases. All right, so we're actually adding the two cases together. Okay, all right. All right, so the next question is odd. All right, if the sum is odd. Now, if the sum is odd, what we need to do is we need to have an even number plus an odd number. Okay, so to get an even number, we need to have 4c1. Just get one number from the even set of numbers, all right, and to get one number from the odd set of numbers. There's only one case here, so we multiply them together. So it's just equal to 4c1 times by 5c1. Okay, all right. So we're gonna move on to question C. I'll finish up to question C, and then I'll leave question D and E for you to try, because they are very similar. This is about divisibility, which it's actually pretty difficult as well. Right. So we're gonna add those numbers together, two numbers together, and how many ways it's divisible by 3. Okay. All right. Now, if it's divisible by 3, it's a bit tricky. What you need to do is you need to think about the number that is divisible by 3. So a possible sum, first we need to think about a possible sum of numbers, right? So we can have like 3, 6, 9, 12, 15, and goes on. Can we have, we can also have 18 if it's possible. Okay, however, I don't think we can have 18 because in order for you to get 18, you need to have a double 9, but there's only 1 9 here, so we need to finish up to 15. 15 looks like it's the largest possible sum you're going to get. Alright, so let's talk about this one in different cases. So let's just say if we need to get a sum equals to 3, how many possible ways that can occur? We only have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that the only possible way is just 1 plus 2. We can only select number 1, number 2. So I'm just going to do number 1 and number 2. Alright, so in that case, that's one way. You can't have any other ways. Alright, for the sum equals to 6, alright, how many ways are possible? Well, in that case, we'll have 2 ways, I think. Number 1 and 5. Number 2 and 4. You can't have number 3 and 3 because you only have 3 ones. Okay, so 2 ways. So I guess for this question, I'm just listing the number of ways. All right, if sum is equal to 9, how many possible ways? Well, 1 and 8, that's one way. We can have 2 and 7. We can have 3 and 6. That works. Can we have 4 and 5? Yep. I think that's all. So we have like 4 ways. So if we continue the process, all right, for number 12, that's 1 and can we do number 12 1? No, can't do 1. So for number 12 has to be start with 3 and 9, all right, the largest 9, and then 4 and 8, and then 5 and 7, and then you can't have 6 and 6. You also can't have 7 and 5 because 5 and 7, 7 and 5 are considered to be one selection. Alright, so now it's 3 ways. Alright, so if sum is equal to 15, which is the last one, 15, 7 and 8 is possible. You can't have 8 and 7. What about 9 and 6? Yep, that's possible as well. So that's 2 ways. Alright, so therefore in total you just need to add all the possible ways together. 1 plus 4 plus 3 plus 2. Actually, did I miss one? Yes, I missed another 2 somewhere here. Okay. Alright, so that's 12 possible way or 12 possible selections for the sum that is divisible by 3. Okay. Alright, I'll leave the question D and A for you to try because that's divisible by 5 and then that's divisible by 6. You can have a look at this question when you're doing the exercise. Alright, very important lesson. Please spend time to try the questions. Try every single question definitely. Let me know if you have any questions. Alright.